Welcome to qnawire.
In this case, what we're going to have is three different vectors in a coordinate plane. First of all, vector A is 60 degrees upwards to the left of the vertical, so vector A is going to be this one with an angle of 60 degrees. Vector B is 75 newtons at 70 degrees below the horizontal to the left, so a little bit more skewed. This one is going to be 70 degrees and a value of 75 newton. Well, let's just put B here for making it more simple. And finally, C is at 10 degrees below the horizontal to the right. So the angle here is theta equal to 10 degrees, and this corresponds to vector C. We want to know what would be the magnitude and the direction of the resultant force for the sum of all of these vectors. So what we're going to do is find the components on the x and y axis for each of them and then sum them up. So the x component for A is going to be equal to, let's look at the drawing. On the x direction, the corresponding function that is going to project a result is going to be the cosine of theta, because cosine of theta is adjacent caret divided by the hypotenuse. So cosine of 60 degrees times the magnitude of the vector. In this case, 50 Newton. The y component is going to be equal to sine of 60 degrees by a similar argument times 50 Newton. Now for B. For B, the x component is going to be equal to, same thing, cosine of 70 degrees times 75 newtons. And now the only thing that we need to be careful of are the signs, because for A, the x component needs to go on the negative direction, the y on the positive direction. On B, the x component is going to be on the negative x direction, and the y component is going to be as well on the negative direction. So sine of 70 degrees times 75 newtons. For C, we're going to do exactly the same. X now is going to be on the positive side, so cosine of 10 degrees times 100 newtons, that is the magnitude of this vector. And for the y component is going to be equal to negative sine of 10 degrees times 100 newton. The result for each of these calculations is going to be the following. So these are the results of each of the components: AX, AY, BX, BI, CX, and CY. So now, if we want to do the sum of the vector A plus B plus C, what we're going to do is an ordinate pair of AX plus BX plus CY, plus CX, comma, AY plus BY plus CY. So we need to sum each of the components, and this is going to be the resulting vector. Another way to label this is AX plus BX plus CX on the I direction, where I is the unit vector on the X position, and AY plus BY plus CY times J, where J is the unit vector corresponding to the Y position. Just for reference here, X and Y. So now we just need to sum these quantities. We get 47.83 on the I direction plus minus 44.541 on the J direction. All of this is going to be in newtons. Again, another way to label this would be the ordinate pair 47.83, comma, minus 44.541, and all of this in newtons. So to know the magnitude of this vector, of the resulting vector of A plus B plus C, This is going to be directly Pythagoras theorem. So the square root of 47.83 squared plus minus 44.541 squared. The magnitude is equal to 65.357 newtons. This is the magnitude of the vector. And now, to know the direction, we need to employ the plot again. We know what are the coordinates corresponding to the resulting vector on x and y. We know that this would correspond to positive x, negative on y, so a vector over here whose component on x, that I'm going to put it in purple, the component on x is equal to 47.83, and the component on y equal to minus 44.541. We can take this directly as a distance just to do the Pythagoras theorem, and we're going to know what is the direction. Again, remember that the resultant is going to be 65.357 newtons. And all of these quantities are going to be in newtons. So we have a lot of options to know this angle theta. Let's just pick the sine because that is a little bit more straightforward. So sine of theta would be equal to minus 44.541 divided by 65 times 0.357 Newton and Newton. Let me just clean it up a little bit because this 6 is looking ugly. 65. So arc sine of this ratio is going to be the value for theta, giving us a value of theta equal to 42.96 degrees. So we know that the direction of this vector and its magnitude is going to be on the horizontal to the right, below the horizontal, with an angle equal to 42.96 degrees and a magnitude of 65.357 newtons. Written down in words, it would be at 42.96 degrees below the horizontal to the right, with a magnitude of 65.357 newtons. So this would be our full answer. You can also refer to that angle as other different options. For example, you can label it as minus 42.96 degrees with respect to the unit circle, or you can take it as 317.04 degrees with respect to this side over here. So both are possible, but because of the way that the problem was posed, I think that this is the best way to put the answer. So that would be all. Thank you very much and have a good one.